Now, hey, here it is. Good news and bad news. This goes back to 2013. And they're talking about, maybe some readers recall Immanuel Velikovsky's 1950 mega bestseller, Worlds in Collision. The book, which caused a real sensation at the time, was an attempt to explain many of the big cataclysms and miracles recorded in mythic and folkloric narratives of ancient cultures. They all had the same story as real astrophysical events. Velikovsky's thesis was that narratives of floods and mass destruction were not just allegorical or metaphorical, but records of events that did take place. Mythic and biblical catastrophism had a historical and a scientific value. Now, here's what he claimed. In Velikovsky's theory, Venus, which is the planet we're talking about, is old, very, very, very hot, spins backwards, was ejected from Jupiter, all right, not Mars. I think they said Mars, but it's what Velikovsky said. It was ejected from Jupiter as a kind of comet sometime around the 15th century BC. That's 3,500 years ago only. Its periodic passage by Earth caused all sorts of havoc. His mythic inspiration came from Greek mythology, in particular the Bible, where Athena, now listen to this now, Athena, which is Venus, was ejected from the head of Zeus, which is Jupiter. In spite of its popular appeal, the astronomical community summarily dismissed Velikovsky's ideas as a key player having been none other than Carl Sagan, who knew a lot about Venus and its atmosphere. He destroyed Velikovsky. They all did. In any case, Velikovsky's celestial catastrophism follows on the footsteps of many claims of these endings due to upheavals in the skies, which they're written about everywhere. He was a contemporary of Einstein. They knew each other, and Einstein died with Velikovsky's book open on his bed. All right, so he was not a nutcase, and he didn't have the information I have now. My information is even much, much better, and he was right. And all of this stuff happened 3,500 years ago, I believe, and it was the great feared god Jupiter said, "You guys messed up," or somebody did, and said, "We're going to destroy all the earth and kill all these giants." And that's what happened. And I'll show you. I have giants right here, and they were all over the earth. Let me show you mine, and then you're going to see how dismissive they are of facts. It's really very, very unbecoming. All right, this is a fingertip. This is a fingertip from a giant, and that's where the bone is right there. All right, there's ligaments here, tendons, and I'm going to show you the actual structure of the skin, and it's nothing more than leather, really. Our skin is the same as the skin on a cow, only a cow has very thick skin. And some of us also have thick skin if we've been attacked enough. Now, this is the bottom of the fingertip. And it is a fingertip, and this is where the apical tuft is, and I have another apical tuft right here. I have tons of this stuff. And an apical tuft sits right at the tip right here, and has all these little balls stuck into these holes, and they run down. You can actually see that round little spot there, and there's you can almost see some of the tendons running off. It's pretty highly eroded. It was just a nice big round fingertip when the fleshy part didn't erode away. This is the pretty tough stuff down here. We're into the toughness of the skin. Now, the fingernail was very apparent on the CAT scan, and this was CAT scan, DNA tested, everything. Now, I'm going to show you in a microscope the fabric of the skin and some of the chemistry, and then some of the blood vessels. And I drilled into these things deeply. I don't know where it was, one of these things, I can't remember now, but I drilled in to where I drill in, and then I drill deeper. You take out the first stuff, and then you did. Now, this was, okay, that was mitochondrial DNA I had tested. All right, that means the mother side. this would be the same as my DNA. Yes, absolutely, it would be the same. We all have the same mitochondrial DNA. It's the mother's side, and even the giants had the same. So if I tested my own DNA, it would test the same as this. But that doesn't matter, because this was what I extracted it from, and it was dense and excellent quality in 2 out of the 3 specimens. This wasn't as good as some of them. But I have all kinds of stuff. I have the whole hand of this. I have knuckles, I have fingers, I have all kinds of stuff from this. And it was DNA tested, CAT scan. I don't bother showing you the CAT scans and stuff. It's been a million times I showed this. But again, this is only mitochondrial DNA. But it was dense, and it was excellent quality. Excellent quality DNA sequence. And one of them was a 36-inch fingertip, huge. And then there was this lung right here. Here it is. Oh, it is right there. It's a left human lung. And this is the fascia, the pleura, whatever you want to call it. You see how flat that is? This was from the flood. This was from the flood. They all died in the flood. Even Caesar here, my goose. He died in the flood too. And he has the same keratins and kerogens. And they fused with aluminum silicates. And that's what causes, this is all called feldspar. That's a bone covered with feldspar. But inside, it's basalt or some other rock, metamorphic, igneous. They have all kinds of names. But all it is they're all covered with feldspar, because inside is the biology. And I have this in spades, my friends, tons of it. Okay, when I said that the DNA sequence will likely be just like mine, I'm pretty sure it is. These are from a nucleotide blast, which means they look for all of these sequences that indicate a certain species. And that's all I asked them to do at Helix Biolabs. I said, all I want to know is this human? Because they look absolutely human to me. You know, the hand was human, the lung was human looking, the finger, everything. So I said, well, all I want to know is it human? And he said, we can search for these sequences, which is the cytochrome B gene and the D loop region. And they all came back as human, 100%. And he said that absolutely 100% are human. Now, I probably going to be just like me. I don't know. Just like you, because apparently the mother's side DNA, the mitochondrial DNA, is identical to everybody else's. I don't know why. And the father's side is what makes it change into different types of looking people and hair colors. I don't know. I really don't know at this point that deep into the genetic interaction. But I do know what I extracted was deep inside, no chance whatsoever that it had any of my DNA in it, whatsoever. And it was dense and excellent quality. And the items are absolutely 100% anatomically exact. There's no way this can be wrong. All right, so this is the DNA sequences, and these are the different specimens. That was the fingertip from the hand, and I have the hand, then I had the lung, which is this one, and then I'll show you the fingertip. Alright, so this was a different one. This one here, and these are all on my property, and I don't know why, it just happened here. This is the blood supply coming in. This little bumper pad is the thing that bumps up against your next bone. That is the fingernail. Now take your time and look at it carefully. Alright, and I can't remember, I think it was about 36 inches from tip to around where the tip is in the front, and the fingernail was absolutely perfect. Well, you know, it's fairly good. And this right here was skin, and I couldn't find any place that I felt I could get any good DNA off of the surface. So I decided I'd bash into it and take off a piece, which I did. And I drilled down in there and took out the blood, because once you get into fingertips saturated with blood, absolutely saturated. So that's what I did, and that's what I sent off from that tip. And let me show you the fingerprints. The fingerprints were very good too. You see this? That's the fingertip that the skin that I broke off, and it literally is glued on just like that. The back of this is really totally separated. When I banged it, it just popped right off. It literally came off just like this, and it's about that thick. Now, these are the sweat pores. You see up here, sweat pores? Each one of these is one of the fingerprint ridges in your finger, same as ours. And it comes up very, very close to the fingernail, just like yours. If you look at yours, you got it very, very close to your fingernail. And that's where it came off of. I was surprised how clear the fingerprints were. Anyway, they're about as wide as one of my fingers. So this is a pretty big guy. And remember I showed you there's a ton of blood in him? There is. And this is where the blood feeds in the front. And then there's two bloods here from the artery and a third one out here, all artery. And then this is all veins. Veins suck the blood back up to your heart and lungs. It's black. The red is the hematite. The black is the magnetite. And they're just absolutely saturated in your fingers. That's why the blood you get out are very, very simple. And they actually just leak. Alright, I want you to look at something carefully now. You see these little spots here? Tendons in place in there. You see them? They're all over the place. That's how your fingers can do this. Otherwise you couldn't do it. There's tendons. Now look at this little spot right here. And don't forget this. Remember I showed you on the big gigantic fingertip there was a little pad on the bottom? Now, and I showed you where the blood was. Well, the big fingertip, they're showing a pad here, but my fingertip is huge like this, so the pad just sits underneath. Because I'm showing the entire fingertip. And that's where that little pad is. Kabish? You following me on that one? Now, let's go in here and look at these tips. You see these fingertips? There's what's called the apical tuft, which I talked about, which is out there right at the tip of the finger, and all of the tendon balls that run from these run up to that apical tuft. That way there you can do this, otherwise you couldn't do it. So that's what the apical tuft is. Alright, this is outrageous. Where do you see this? This is when this first came out of the ground. Like I said, this hand was in all kinds of different pieces and different types of decay. And this was the apical tuft, which is completely separated from a fingertip, one of the fingertips. I found a bunch of stuff. Now, you see this pattern right here, that black pattern? You see that? That's a distal phalanges. I'm going to show you. You see these two holes here? Well, here's the actual fingertip. You can't see that anymore. They oxidize. You see, you can't probably see that black anymore. But when it first came out of the ground, it was very apparent. Now, check this out. You see this here? That's the fingertip. That's really inside where the bone is in the fingertip. The rest is still a little bit of flesh left. Now, this was the vein side. You see that little pinchy looking thing right there? You see that? And there's one up under here too. Those are both the veins. Remember I showed you there's two on the side of the veins, two on the side of the arteries, and then a vein and an artery at the end, and that's exactly what it is. Now, the veins do not blow out because they have a little clamp inside. So there's another one up here that didn't blow out. Now, look at that. That's the artery. Blew completely right out. That's the artery. Blew completely right out. Blew completely right out. And that is the apical tuft. And I can show you that pattern. Remember that pattern. See how cool is that? That's that same pattern right there. That's that, and that's the distal phalanges. And then there's that little thing that little round spot under there. Now there's tendons. These are really tight buggers. And then there's that apical tuft, and this is the bone. And these come out in a lot of times, well, almost always, and you end up with this top piece. Alright, everybody says, oh, you can't get blood out of rocks. That's insane. Rocks, if they are in the right preserved area, the blood is still completely inside, and they're packed with mud. Red mud is nothing more than flesh. That's all it is. If it's red, clay, muddy, it's flesh. It's eroded from some creature's flesh. That's all it is. And then the blood stays inside. When you take it out, it sort of drains right out of there. That's a scab. And that's a bone. I don't think it was this bone, but I have so much of this stuff. I don't know where anyway, I did a little research on this particular scab, and I took the scab off, and you have fibrin underneath, which is a clotting fiber. And then below that, you have this is what they call a bone foramen. And inside the bone foramen, after you take off the scab and that fibrin, you have the red blood side right there, and you have the black blood side right here. Vein and artery. Because you have to have a vein and an artery. You can't have just one side of blood. You've got to have two sides of blood. You see those two little holes? There they are. Now, I showed you the lung I have here. It was like saturated with blood here when I first took it out of the ground. And this one literally leaked blood out of it. You see up here? And again, if you're in the correct conditions, look at that. There were little blobs of blood coming out of some of these little alveoli. And that's what they are. You see these holes here? I don't know if you can see that. Let me come up over here. Sometimes you have to get in just the right way to see there's cavities. But they're the alveoli, which are in your lungs, where air goes in here. Here's what happens. When you breathe, air comes down your esophagus, and it goes in here. It fills all these little holes. These would have been holes. Well, when holes empty out, and water continuously flows through as silicates, it creates silicon deposits, quartz. This is nothing more than quartz now. And, there's some bloody little spots left in it, as you can see. But primarily it's quartz. But it still has, the connective tissue is tough. It's tough. And you see, and the connective tissue is what surrounds every one of your alveoli. And that's why you see all those little keyhole-looking things. You see them? And that's where you breathe through. Now, this was the one that had the fascia on it. This was DNA tested. And that one, the other one wasn't. I didn't bother. This one here was DNA tested, and it still has all of its coating, the plur. If you look, hold on, let me back out of this. If you look at the anatomical, it goes all the way inside. On the outside is the fascia, pleura they call it. And then you start pulling back tissue, and you end up getting into the alveoli. Now again, this was from that big fingertip, and I'm going to show you a knuckle and some tendon from it too, which ran off here somewhere. I found all kinds of stuff. This is a left hand. All right, the thumb runs off this way. This is the pad that runs around your hand. Just look at it. It's a red bumpery pad. Now, this little cleave right here, if you pinch your hand together, you'll see you have that same thing. You see? It's right there. Now, this stuff here is the grip skin. And if I showed you, they call it friction skin, grip skin, but you see how it's peeling off? It's silvery. It's a totally different skin, totally different than the fleshy-ish part underneath. Totally different than any other skin on your body. Your heels and your toes and your fingers and your palms and so forth. And that's why it peels off. And it's very, very tough. So anyway, I have this right here, which is a knuckle. And it's eroded completely down. This is like an autopsy. I'm telling you, the stuff I found, I just can't believe how fortunate I was to find this. It's just laying there. I didn't do any big searching or excavations. It's just all over my property. So this is a knuckleball. This came out of the same hole where all of this stuff came out. And even the little lung here, and all kind. I think the goose came out there too. Anyway, it's hard even to talk about because it's just so staggering, unbelievable. But that is the bone ball of a knuckle. All right, and I'm absolutely certain of it. And this is strictly only the bone. It's eroded away all the other stuff. And guess what? The other side didn't. The other side kept everything. You see how this side is missing everything down to the bone? It's bad to the bone. Well, this one didn't go bad to the bone. This one stayed all of its articulation here. Now, what do I mean by that? Well, here's what I mean. Let me turn the slide off. Maybe I can see. You can see it better here. Sometimes you got to see the, but you see that little circle there and the surrounding part. That is a tendon, and that tendon is running right off of here. You see, this is literally right here, and the tendon is running right off of here. All right, it's actually just like this. And that tendon is running right off the side of one of the fingers. And the bone ball is right here. This is the ball. All right. And this is the muscle that surrounds the ball. And this is the tendon that comes down the side and makes you be able to do this. Otherwise you couldn't do that. That's what this is. This is the muscle. This is the bone ball. Now, it was laying flat. You see how flat that is? The hand was upside down. It was laying like this, apparently. That's all I can assume, because this came out of an excavation, and then I went to get some rocks one day, and it was just all this stuff was laying there. And I said, holy smokes. Now, this is that bone ball right there. The marrow and all the stuff inside just turns into mud. It's just like I said, this is nothing more. Mud and clay, red clay and mud is nothing more than eroded flesh and bone marrow and so forth. And you can see the red ferrous oxides because there's a lot of blood, a lot of hematite inside. You see it? In the muscles. I've shown that before. And we could look at this. Well, we probably should. Hold on. Okay, we're going to be looking at this in a microscope. Now, what are you looking at? Right here is the bone ball. You see this right here? That's the interface between the bone ball and the muscle. Now, we're going to look at it in a microscope up above and see if we can determine what we're looking at here. Hold on one second. Okay, it's pretty obvious what we're looking at is the muscle with all the blood in it. And this is where the bone ball is. Now, let's come down the bone ball. And you see it comes all the way out to the edge here and wraps around. It's broken up a little bit here and there. I don't know, there's a spot in there. But this is where the blood is. Alright, now, I'm going to turn the lights on and point down at it and you'll see. But it's just quite obvious. And this, you could scrape this away and then drill into that and get some pretty solid DNA. Now, I'm covering, you know, as soon as you put the light on, you lose all the detail of the light. All right, here's what we were looking at right here. That was where all the red blood is. And this is where the bone ball is. And again, flat as a pancake because of the flood. And this side is the muscle fibers, right there. See them? Sometimes you gotta move around this, and then this one here is the tendon fiber. That little circle there is the core of it. And that's an abrupt transition. They break just as flat as a pancake. See that? Just as flat as a pancake. See that? That's not from laying there flat on it. They break flat. This is where it was laying. That was laying like that. This is an abrupt transition, and they break flat as a Z pancake. That's it right there. See it coming down? Stops right there. See all the blood under here? I'll tell you, everything's different than we thought it was. It's a whole new world, my friends. Well, it's a whole old world. How about that?
Cautionary